we're going to make a special note on array operations. And as you know, during array operations, the sizes of two arrays on both sides of an operator must be the same. However, there are two exceptions. The first exception is one of the array is a scalar. In that case, the scalar will be expanded to a two-dimensional array that fits the size of the other array. For example, I have an array here, A equals 1, 2, and this is the first row. The second row will be 3, 4. And if I do A plus 5, and even though the different sizes, however, the operation will still be successful. So that is the outcome. And you will see it's 6, 7, 8, 9. So this is actually equivalent to A plus a new array, which is the same size of A, and which is expanded from the scalar 5. So the new array will be 2 by 2, and all the elements will have the value of 5. And you see this output is the same as the previous output. Now, the next special case is a little bit confusing, and it is that when the two arrays, one is a row vector and the other is a column vector. For example, if I say A is a row vector, 1 and 2, and B is a column vector. So you can enter column vector as 1 semicolon 2, or 1, 2, and with an apostrophe. So in this case, I will do this. So you get two arrays. One is the row vector and the other is column vector. And when you do the addition of these two, A plus B, if you look at the sizes of the two arrays, they don't match. However, it can still work. And when you look at the answer, it's 2, 3, 3, 4. This is how the MATLAB works. When it do the operation and they found that both arrays are vectors, so they try to expand both arrays to the same size of array. So in this case, they will expand the row vector A into a two-dimensional array so that the number of rows matches the number of rows of B. Similarly, they also expand the B into a two-dimensional array so that the number of columns matches the number of columns in A. All right, so this is actually equivalent to this. So for the A, it will expand it into 2 by 2 because in B, there are 2 rows. So it just duplicates the rows. So this is what's happening. So if we duplicate the rows in A, so the A will turn into 1, 2, 1, 2. In B, they will duplicate the columns. So from 1 column to 2 columns. And in this case, when you look at the rows, there will be 1, 1, 2, 2. And when I hit enter, you will see that they have the same output. So this is a very special case. And next, we're going to talk about how to use operations to create some special array. For example, let's say we're going to create an array of 5 by 5 two-dimensional array with zeros on the side, and in the middle, the 3 by 3 elements, there are values of 2. So this is how it works. And first of all, you will create an array with all zeros. And it's a 5 by 5 array. So this is what you can do. So you use the function zeros and use the one input as 5, and if you hit enter, you will create a two-dimensional array of 5 by 5 with all these zeros. So what we want to have eventually is an array that it's the same size as this, it's 5 by 5, but except on the edge they're all zeros, but in the middle, that's this 3 by 3 section, it should have value of 2. So this is what I'm going to do. So we just use a so-called subset replacement. So we're going to replace the values over here to value 2. So how can we do that? Well, this is how you do it. So you, first of all, you need to index this section. So it's a column 2 to column 4, and also from row 2 to row 4. So it's row 2 to row 4. This will give me row number 2, 3, 4. And also the column number is 2, 2, 4, 2. And then it should equals to a 3 by 3 matrix. So this 3 by 3 matrix should be all 2s. And this is how you do it. So you have a 2 times 1s. And in this case, it is 3 by 3. All right, so let's hit enter. Now, this is a special array that you're going to create. All right, the next example is that we're going to still create a 5 by 5 array, but in this case, the center row and center column are the values of, let's say, 10. How can we do that? Well, same thing. We start with all zeros. We started with all zero. The next, we're going to replace this row, that's this row 3, with 5 1s. And you have to be very careful here. So if you want to get the entire row, this is how you do it. So we first specify the number of rows, that's 3. And what about the index of this row? You can use 1 comma end, which covers the entire row, or just in short, you just use a comma. And this means the entire row, okay? And this, in this case, you want to replace it with a vector, actually a row vector with 5 1s. So, or 5 10s in this example. So you will say 10 times 1s, because this is row, so you have to specify one row, 5 elements. Here you go. You will see 5 10s. And what about to replace this as this column as 5 10s? Same thing. So in this case, I will just do an edit of previous command. Now, because we're talking about columns, so it includes all the rows. So the row will be a comma to replace the entire column. And also you will specify which column you're going to choose. So this is 3. And in this over here, you have to specify a column vector. So it's 5 1. And here you go. So we got an array with a cross with 10 values, and the rest will be zeros. Okay, so in this operation, actually, this value will be replaced twice, both with 10, so that's fine. In short, you can use operations to create an array of special pattern.